Hi everyone, we're doing this math paper today. This is 9709 paper 3-2, May June 2023. The time is 1 hour 50 minutes. Before we begin, let's take a look at the threshold. So for this particular paper, A was at 52, B was at 45, C 36, D 27, and E was at 17. Alright, let's write that down over here. I plan to do the other P3 papers as well soon. But before that, I'm planning to release chemistry and physics content, paper 2, paper 4, and 5, before your October-November series. So I'll try to release them as soon as I can, okay? All the math papers as well as physics, chemistry. I also plan to expand to O-levels content as well, so wish me luck. Work has already started, so let's write this down. The full mark is 75. So yeah, A was at 52. B was at 45, C was at 36, D was at 27, and E was at 17. So A star, if you look at the gap, what's the gap like? It's around 9 marks. This was 7. So yeah, 7 to 8 marks above. So it should be at around 60 or 61. 60ish, 59 to 60. A star should be at 60. So if you do get a 60 while practicing this paper, you're good to go. Okay, let's begin. Also, before we start, I want to talk about my Patreon that we launched recently. If you do like the content, please do consider supporting me on Patreon. It's patreon.com/CAIE paper solved. There are 3 tiers. One tier just for support, another tier where you get access to my chapter-wise notes for physics and chemistry, ad-free videos, as well as requests for question paper solving in my next YouTube video. I can help you in sessions over text where you can send me your problems through email. Also, you get access to my solved papers, the recent ones for P1, M1, P3, S1, as well as, you know, physics, chemistry, and bio. Paper 1, paper 2, paper 4, and paper 5. That's what's included here. And here in the highest tier, you get access to all of those priority for question paper solving requests, as well as one-on-one video calls with me where we solve your personal problems once or twice a month. Okay? So yeah, if you feel like that's helpful for you, please do consider supporting me. Without further ado, let's begin. Starting with question number 1. Solve this inequality. Okay. Let's begin. So you can do it algebraically, or I always prefer drawing the graph. I prefer the graphical method. So let's see. So for this one, it's 5x minus 3. So 5x minus 3 is equal to 0, y is equal to 0, x is equal to 3 by 5. And when x is equal to 0, 0 minus 3 is equal to y. So y is equal to minus 3. So we have our coordinates now. When x is equal to 0, y is equal to, this is minus 1, minus 2, y is equal to minus 3. And when y is equal to 0, x is equal to 3 by 5. 1, 2, 3, 4. When y is equal to 0, x is equal to 3 by 5. 3 by 5 means 0.6, right? 3 by 5 is 0.6. So it should be somewhere over here, just behind 1. Okay, so if we draw the graph, it is something like this. I'm drawing a dotted line because since it's a modulus, the negative part does not exist, right? So rather than that, it should be passing through here. So this is what the line looks like. And also after the reflection, it's like this. So this is our graph. It's quite steep as the gradient is 5. Moving on to the next part, we have 2 times 3x minus 7, which can be written as 6x minus 14, right? So let's do the math for this one. 6x minus 14. So when x is equal to 0, y is equal to minus 14, and when y is equal to 0, 6x equals to 14, or x equals to 14 by 6, which is 7 by 3, or 2.33. So when y is equal to 0, x is equal to 2.33, somewhere over here. And when x equals to 0, y is equal to minus 14. Where is minus 14? It's really low, okay? Minus 2, minus 4, minus 6. It's too low. Minus 2, minus 4, minus 6, minus 8. I think I chose the wrong scaling, clearly. It's fine though. Minus 8, minus 10, minus 12, minus 14. This is minus 14. So yeah, the graph actually kind of looks like this. Now over here, 2, 4, 6, 8, 10. I just need to shift it a bit below. Wait up. 2, 4, 6, 8, 10, 12, 14. 14 is over here. So this is what the graph looks like. Since it's steeper, right? Since it's steeper, if you follow the line, let me draw this first. Wait. Let me draw the continuation. Looks like something like this. Now, since it's steeper, it's going to cut the pink graph. I think I need to draw a smaller graph because it's getting hard for me to draw. But I can try doing this. Wait up. Nah, it's not working. I need to draw a smaller graph. Extremely sorry for this. I just need to change the scaling because it's too hard to draw. Here we go. Okay. So this is 4, 8, 12, 16. On the other hand, this is minus 4, minus 8, minus 12, minus 16. Okay. So I'm going to draw the purple one first. So at x is equal to 0, it's y is equal to minus 14. At x0, y is equal to minus 14 over here. And at y0, x equals to 7 by 3. So similarly, if you do the scaling here, what do we get? This one over here is 4. So this one is 8, kind of like that, right? So 7 by 3 is 2.33. So 2 is somewhere over here. 2.33 should be over there. Okay, so let's draw the graph. It is somewhat like this. I need a scale for this, honestly. And yeah, 14 is over here. If I draw the reflection, it will be something like this. Yeah, there you go. Man, this is so hard. Quite steep. On the other hand, if you draw the other graph, I'll try a different color. Like, you know, at x0, it's y minus 3. Minus 3 should be somewhere over here. And at y0x is 3 by 5. 3 by 5 is 0.6. So since 1 is over here, 0.6 should be somewhere over here. So it looks like this. This is what the graph looks like. It should be dotted though. And 3 is over here. So if you connect it, it's kind of like this. There you go. Now, if you think about it, the gap between these two lines will actually keep on increasing. Why? I'll tell you. Check this. The logic is quite simple. Basically, the purple graph has a gradient of 6, while this graph has a gradient of 5. So the purple one is steeper than the green one, which means that over time, as you keep on going ahead, the angle will increase. Okay. On the other hand, here, since it's less steep, why don't I find out the value at another point for this graph over here? What if I use, maybe 8? So if I input 8 over here, or maybe 4 over here, 4 into 5 is 20, 20 minus 3 is 17. So at 4 it's going to be 17. 4, 8, 12, 16, this is 18, 17 is somewhere over here. So the graph looks like this. There you go. Now, basically, on the other hand, on this end, right, since the purple one is steeper, what will happen at one point? The angle between them should keep on decreasing, right? The angle between them should keep on decreasing. For example, if I draw a line like this, wait, something like this, okay? Let me just move it over here. The graphical method for this was quite hard, honestly. There you go. Yeah, it is in fact something like this. It will keep on going, and at one point, what will happen is it is going to intersect the purple graph again. On the other hand, the purple graph is steeper than the green one. So what's gonna happen is it's gonna intersect it at a point. Thing is, it's hard to draw because it's after 8 clearly. It's after 8. But yeah, after 8, at some point they're gonna intersect, okay? So that's what we can figure out. I'll try to draw another line over here. Wait up. Okay, so it is something like this since it's 6x. Yeah, it is probably something like this. There you go. Although I feel like it's gonna be a bit farther away. Something like this. Wait. There you go. After 8, it looks like somewhere after 8. Okay. So why is this happening? We have to understand the logic. Mainly because, hear me out. This has a gradient of 5x while this is 6x. So purple is steeper than the green one. So on the left hand side, the purple will keep on going here and the green one will keep on going here. As a result, the angle between them will keep on increasing. Here they intersect once, and since the purple one is steeper than the green one, it is going to overtake it once more later on. So how do we solve this honestly? This part of the graph over here is the original one. This is 6x minus 14, while this part over here is the modulus part, which is modulus of 6x minus 14 or minus 6x plus 14. Similarly, for the green one, the one on the left over here is, modulus of 5x minus 3, while the one on the right is 5x minus 3. So as you can see, the green 5x minus 3 part, it is intersecting the purple line over here as well as here. So it is intersecting the purple one twice. Okay. So once we can go for 5x minus 3 is equal to 6x minus 14, which is minus x is equal to minus 11 or x is equal to 11. So that is our answer over here. This part, this one over here, as you can see, is clearly 11. That's the point. Okay. That's why I was saying it must be after 8, or else it makes no sense actually. 4, 8, if this is 12, yeah, I think maybe then the graph should be like this. Wait, let me fix it just a bit. Should be over here. There you go. So that's one answer. What about the other one? 5x minus 3 is going to intersect the modulus of the purple graph, which is minus 6x plus 14. So 11x is equal to 14 plus 3 is 17. X is equal to 17 by 11, which is equal to 1.55. Okay. So now, why is the graphical one better? Because you can easily find out the inequalities. So 2, 3x minus 7 must be greater than the other one. What does this mean? That the purple one must be greater than the green one. So clearly, when is the purple one above the green one? On the left of this point, because there's a gap here, so we can say it is on the left of 17 by 11. That's 1 point. And again, when does the purple one exceed the green one? Mind that the green one is above the purple one here, but over here the purple exceeds the green one. So we can say after 11, right? After 11. So, and x is greater than 11. These are our points. Okay. If you are wondering how do we do it the other way, I'll teach you that one as well. This is option 2. So you can go for the whole square method. 5x minus 3 whole square is less than, what is it? 2 times 3x minus 7 whole square. So what do we end up with? 25x square minus 30x plus 9 less than 4 times 9x square minus 42x plus 49, or 25x square minus 30x plus 9 is less than 36x square minus 4 into 42, 168x plus 4 into 49, which is 196. So if you do solve it, what do you get? 25 minus 36 minus 11x square minus 30 plus 168 plus 138x, 9 minus 196 minus 187 is less than 0, or 11x square minus 138x plus 187 is greater than 0. Now, if you solve it using the calculator, 11 minus 138, 187, we do get the two critical values. We get the same critical values, and hear me out. The critical values are 11 and 17 by 11. Now, 17 by 11 and 11. This is a minimum curve, so it should look like this. We want it to be greater than 0, right? So x is greater than 11 and x is less than 17 by 11. But in this method, since it's not graphical, you need to check, because sometimes there might be a false answer. Could I clarify? Sometimes there might be a false answer. So you just have to input it in the equation and check. Okay. For example, what equation did we have? 5x minus 3 is less than 2 times 3x minus 7. Okay, so let's check. If I input any value which is greater than 11, maybe like 12, so I'm going to input 12 here. 5 into 12, 5 into 12 minus 3, which is 57, and then 3 into 12 minus 7 into 2, which is 58. Is this fine? So yeah, this is good. I just checked. Now I'm going to input this less than 17 by 11. What does 17 by 11 mean? It means 1.54. So what does less than that mean? It actually indicates 1. Any value less than 1.54. I can input 1 over here. So 5 minus 3 is 2. And there 3 into 1 minus 7, which is minus 4. So it's actually going to turn into 2 into plus 4, which is 8. 2 is less than 8. So yeah, that's also okay. So we just checked that as well. Okay. But yeah, I always tell my students, encourage them to, draw the graphical one, because sometimes they ask you to sketch the graph. But in this case, drawing it was quite a hard process, right? So yeah, sometimes option 2 is a better thing to do. Okay. Now for number 2, I actually had that done previously. So we have to use the laws of logarithm. So On the right side, it can be written as ln x square minus ln 2. Then I can bring them together using ln a minus ln b, the formula. So we get ln 2x square minus 3 is equal to ln x square by 2. I can get rid of the lns on both sides. I ultimately end up with this. 2x squared minus 3 equals to x squared by 2. Then I cross multiply with 2. We get 4x squared minus 6 equals to x squared, or 3x squared equals to 6. And finally, we get x squared is equal to 2. Now, we get two answers. X is equal to plus minus root 2. However, we need to get rid of the negative one because we know that ln x or x cannot take negative values. Negative values of ln do not exist. So this is our final answer only. One answer only, okay? That's what you guys need to realize. Okay, pretty straightforward. Question number 3 now. On an Argand diagram, sketch the locus of points satisfying this equation. Okay, so let's do this. So if you ever see a modulus on one side and length on the other, that actually represents a circle. Okay, so what is the center of the circle? It will be the alternate one, right? Like you gotta, it's like this: z plus 3 minus 2 1 equals to 0. So z is equal to minus 3 plus 2y, the inverse of these, not inverse, or the other sign, negative of that inside. Okay, so it's like a factor and we're getting the solution. So if I do this properly, we are getting 1 2 3 1 2 3 1 2 3 1 2 3. Fine. So it is at minus 3 plus 2. This is the imaginary axis and this is the real axis. So minus 3 plus 2 over here. And what is the radius of the circle? It is 2. The radius of the circle is 2. It will go 2 units up and down. So 2 units down, then 2 units are 1 2 3 4, 2 units up, 2 units to the right, and then again 1 2 2 units to the left. Now I'm just going to try to draw the circle. It's going to be something like this, or let me just bring a shape over here, then I think that's going to be better. Something like this, yeah. There you go. So it is a circle with center minus 3 plus 2, and the radius is 2 units. That is basically the gist. There you go. Now 2 4 minus 3 minus 5. Okay, find the least value of argument, sorry, this is not argument, modulus of z. So when they just say modulus of z, that means that you need to find it out from the center. Okay, so now we have to find out the least value of argument of z. Okay, so we have to find it from the center, and any modulus represents a length. So what is the least value going to be? It is actually going to be this length, but finding out this length is rather impossible. So we are going to apply a technique over here. Why don't we just find the length from the center of the circle? Why don't we find out this length and then subtract the radius? If I subtract the radius, then we are going to find out the smallest length, the least value of the modulus of z. Okay, so to find this out, it's pretty straightforward. This is actually a right angle triangle. This is 2 and this is 3. So we can find out the longest length. Why don't I give this a dotted line and this one will be bold. Okay, so let's find out. So we can write 3 square plus 2 square is equal to L square. So what is the value of L square? It is 9 plus 4, which is 13. So L is equal to root 13. Now what's the next step? Modulus of z is going to be equal to root 13 minus the radius. What is the radius of the circle? It's 2. So that is my final answer. If you show it on the diagram, that's more or less enough. Okay, you don't need to mention anything else. Moving on to question number 4. I also had this done. Let's begin. So solve the equation of 2 cos x minus cos half x equals to 1 for 0 to 2 pi. The domain is from 0 to 2 pi or 0 to 6.28 radians, right? So here's the thing. You cannot solve this equation because one of them is in cos half x while the other one is in cos x. So you need to bring it to the same version, okay, of x. So we know that the identity for cos 2x has 3 variations: 2 cos square x minus 1, 1 minus 2 sine square x, or cos square x minus sine square x. Now, similarly, there are 3 other formulas, like there are infinite variations. Cos x can be written as 2 cos square half x minus 1, or 1 minus 2 sine square half x, or cos square half x minus sine square x. Now, here's the thing. Basically, this angle over here will be double of this one, right? Similarly, we could also write cos 4x is equal to 2 cos square 2x minus 1, get it? So this one will be double of this always. So I'm seeing cos half x over here. I'm seeing cos half x over here. I'm also seeing cos x over here. Now, here's the thing. You need to realize that you always need to write the higher one in terms of the smaller one, okay? For example, if we had cos 2x and cos x over here, we would write 2x in terms of x. If we had cos 4x and cos 2x over here, we would write 4x in terms of 2x. And since we have cos x and cos half x over here, we're going to write x in terms of half x. That's the rule of thumb, okay? So I am going to make cos x the subject. So we have this equation: cos x equals to 2 cos square half x minus 1. So yeah, there's 2 beforehand over here. This 2 over here is this one over here. And you know, cos x can be written as 2 cos square half x minus 1. 2 cos square half x minus 1. And yeah, we have minus cos half x equals to 1. I just applied the identity of cos x. Now I'm going to break down the brackets to get 4 cos square half x minus 2 minus cos half x minus 1 is equal to 0. I brought the 1 on the left hand side. And after further simplification, we can write this as, I skipped a step, 4 cos square half x minus cos half x minus 1 is equal to 0. So we can let cos half x be a, so it can be written as 4a square minus a minus 3. Sorry, this should be minus 3, right? Not minus 1. Is equal to 0. And yeah, after you solve the quadratic equation, you are going to get cos half x equals to 1 and minus 3 by 4. These are what you're going to get. Now, if you solve to find out the basic acute angle, okay, basic acute angle alpha, we are going to get, change your calculator to radians, cos inverse 1, we get 0. And you guys know the rule for cos, right? The rule for cos alpha is, or cos x is, after you do cos inverse, it's going to be alpha and minus alpha. So 0 and minus 0, they're the same thing. And to get the other variations, we're going to add 2 pi and subtract 2 pi from it, right? So 2 pi and minus 2 pi, those are the variations. Similarly, we're going to do cos inverse minus 3 by 4. So we are getting 2.419. I think I should have used more significant figures. Let me do it again. So I'm getting a value of 2.419 and also alpha and minus alpha, so which is minus 2.419. Now I know that my domain is positive only. So what am I going to do? I am going to ignore this negative value. However, I'm going to find out the next solution for this. How? By adding 2 pi to it, which gives us a value of 3.864. I can also, this was found by adding 2 pi to this. I can also find another one by, doing this. 2.419 or cos inverse minus 3 by 4 plus 2 pi, which gives us a value of 8.702. Okay, now what's the next step? We know that this alpha is actually, half x. So x will be equal to double of that value. So 0 times 2 is 0, 2 pi times 2 is 4 pi, minus 2 pi times 2 is minus 4 pi, which are outside the domain. So I can only take 0 as an answer from the left hand side. And from the right hand side, we know that half x is equal to all of these. Half x is equal to all of these over here. So half x equals to 2.419 minus 2.419, 3.864, and 8.702. Therefore, x should be equal to double of this. So 2.419 times 2 is 4.838. Then there's no point doing the negative one, but I'll still do it. Minus 2.419 into 2 is minus 4.838. And then 3.864 times 2 is 7.728, and 8.702 into 2 is really high, 17.404. So my 2 pi, if you find out 2 pi in the calculator, it is actually 6.28. So what is only included in this domain? Only the first one, right? So what is my final answer? Therefore, x is equal to, I'm taking 0 and to 3 significant figures, 4.84 only. And that's it. Those are my answers. The others are excluded. Moving on to question number 5. How many are there in total? I think we have 11 or 12. 11 questions in total. Okay. We're going to be done in an hour, hopefully. The complex number 2 plus yi is denoted by a, where y is a real number and y is less than 0. It is given that if a is equal to a cubed minus a squared minus 2a. By the way, recently I've seen there's been an increase in my audience from Malaysia and UAE recently, so that's great. There are also a lot of people from Pakistan, Bangladesh, India, and Saudi Arabia. There are a few people from the US, Australia, New Zealand as well. But yeah, there are a lot of Indonesians as well, and some people from Mauritius. And with the channel is expanding, I hope we are gonna hit 10k subs soon, which is awesome. It's gonna be my first milestone. Let's move on then. So find a simplified expression for f a in terms of y. Okay, so we know that f a is equal to a cubed minus a square minus 2a. Now if we input this over here, 2 plus yi, let's try doing this. If a is equal to 2 plus yi whole cube minus 2 plus yi whole square minus 2 into 2 plus yi. Okay, so how do we do this? If a is equal to, what's the formula for this? Remember, it is basically 3c0 into 2 cube plus 3c1 into 2 square and yi plus 3c2 into 2 to the power 1 and yi whole square plus 3c3 into yi whole cube. That is 1 minus, what is this? 4 plus 2 to the 4, 4yi plus yi, y square I square minus 4 plus 2yi. So after further simplification, we actually end up with, oh, by the way, one thing you need to know is I square is minus 1 and I cube can be written as I square into I. Okay, so if a is equal to 3c0 is 1, so 8, 3c1 is 3, 3 into 4, 12, 12yi, 3c2 is 3, 3 2 is 6, 6 y square I square plus y cube I cube minus 4 yi minus y square I square minus 4 minus 2yi. So if a is actually equal to, we can get rid of a few things. This minus 4 and minus 4 is minus 8, plus 8 is 0. So we can write 12yi. This turns into minus 6y square. This turns into, I just told you that I cube is equal to I square into I. So I cube can be written as minus I. So minus I into y cube is minus y cube I. Minus 4yi. Minus 2yi. That is minus 6yi. And this turns into plus y square. So what is it finally? Minus y cube I minus 5y square plus 6yi. Now if you take common, 5a is equal to minus 5y square plus I into 6y minus y cube. This is it. This is what they wrote in the marxism. Okay. Given that the real value of fa is equal to minus 20, find the argument of a. So they said that the complex number 2 plus yi is denoted by a, where y is a real number and y is less than 0. Okay, y is less than 0. And the real value of, so let's try to figure this out. This thing over here, right? If a is equal to minus 5y square plus I 6y minus y cube. So you guys got to understand something, alright? This part over here is your real component and this part over here is your imaginary component, okay? So we can actually equate them, can't we? Can't we write that minus 5y square is equal to minus 20? So y square is equal to 4. Therefore, y is equal to plus 2 and y is equal to minus 2. However, since they said that y has to be less than 0, this is not applicable. So this is our only answer. Now, that is not the end though. They want us to find out the argument of a. Okay, they want us to find the argument of a. What is a in the first place? A is 2 plus yi, right? A is 2 plus yi, or a is equal to 2 minus 2i. So if we draw that on an Argand diagram, 1 2 1 2 1 2 1 2. So 2 minus 2i over here. So there you go. So the argument is going to be something like this. So 2 and 2, right? So if we do it, tan alpha is equal to 2 by 2. Therefore alpha is equal to pi by 4 degree. I just found that this is pi by 4, since tan inverse 1 is 45 degree, and since it's below the x-axis, the argument of a should be equal to minus pi by 4, since it's below the x-axis. Okay, so that is all the working involved. Interesting sum. Question number 6, let's go. The equation cot half x equals to 3x has one root in this interval denoted by alpha. Show by calculation that alpha lies between 0.5 and 1. This is iteration, right? This is iteration. So we can make a function. So I'm making a function f of x is equal to cot half x minus 3x. This is my function, okay? So once I'm going to input 0.5 over here. So what is cot half x? It's essentially, your calculator needs to be in radians. It's 1 by tan half x, right? So tan 0.5 into 0.5, then 1 divided by answer, which is 3.9163 minus 3 into 0.5 minus 1.5, which gives me a value of plus 2.416. Now if 1 is equal to basically 1 by tan half minus 3, so tan half 1 by answer is equal to 1.83 minus 3. Answer minus 3 gives you a value of minus 1.17. Okay, so since the sign changed, we have to complete our argument. We can say that since the sign of fx changed between x equals to 0.5 and x equals to 1, the root lies between these two values. That is the logic behind this. Okay, show that if a sequence of positive values given by the iterative formula converges, it converges to alpha. Okay, now we have to show that it converges to this over here. Let's begin. We can write that x is equal to 1 by 3x plus 4 tan inverse 1 by 3x. So I am going to do cross multiplication. 3x is equal to x plus 4 tan inverse 1 by 3x. Now I can bring the x on that side. I want to go to this, right? So it has to be cot half x. Interesting. Okay, so twice x is equal to 4 tan inverse 1 by 3x, or if you divide 4 over there, 2 by 4, which is half x, is equal to tan inverse 1 by 3x, or if I bring tan over to that side, tan half x is equal to 1 by 3x, or thrice x equals to 1 divided by tan half x. Therefore, thrice x is equal to cot half x, shown that it converges to alpha. Is that fine? Okay. Now let's perform the iteration. Use this iterative formula. This is the one they're talking about. Let's go. So you can pick x1 as this or any value in between. It's up to you guys. Okay. So yeah, the left one is x in plus 1, while the ones inside are xn. Okay, so I'm gonna pick x1 as 0.5. Make sure you have radians. So I'm going to write this equation, this part, in my calculator. Let's do this. 1 by 3 alpha x plus 4 tan alpha 1 by 3x, then close the bracket again. Now let's begin. It differs on which calculator you have. Please just look, YouTube it. For example, I'm using FX991 ES Plus right now, Casio. So I press calc, the button below shift. I press the value I want to input, 0.5, and I press equals to. In the newer calculators, you have to press equal to twice. So give all your answers to 4 dp results, and the final one to 2 decimal places. So x2 is actually equal to 0.9507. Now we just go further. Calc answer. I'm going to input this answer to my equation again. Equals to, I'm getting x3 as 0.7665. Then calc answer again. x4 is 0.8024. Calc answer 0.7924. Calc answer again 0.7950. So when do we stop? When we see that it has matched in 2 decimal places for the last 2. So this is 0.95, 0.77, 0.80, 0.79, 0.80. It still hasn't matched yet. So we're going to go for x7 and x8. Calc answer, which is 0.7944. Calc answer 0.7945. Calc answer. We could stop there. 0.7945. See this? It has matched. This is 0.79, 0.7, 0.80, 0.79, 0.79, 0.79. If you keep on going further, it's gonna match. So typically I wait for 3 till I'm 100% sure, but you can just get 2 and you can confirm that x is in fact 0.79 to 2 decimal places. That is your final answer. Okay, so please do comment below if you have any queries. Moving on to question number 7. The equation of a curve is 3x squared plus 4xy plus 3y squared. If we ever see an equation like this is simply implicit differentiation. Okay, let's go. So let's differentiate it. 3x squared plus 4xy plus 3y squared equals to 5. I'm performing the differentiation. It is 6x. Now product rule. Plus 4y plus 4x into dy by dx. I first differentiate 4x, so that's 4y. Then I keep 4x normal and differentiate y, which is dy by dx, plus 6y into differentiation of y, which is dy by dx, is equal to 0. Now we get 6x. I'm going to keep the dy by dx on one side. 4x into dy by dx plus 6y into dy by dx is equal to minus 6x minus 4y. Then I can take dy by dx common. 4x plus 6y is equal to minus 6x minus 4y. Therefore, dy by dx is in fact equal to minus 6x minus 4y divided by 4x plus 6y. We can further simplify, and the minus has been taken common. So dy by dx is equal to 3x minus 2y divided by 2x plus 3y. And there's a minus sign in front. Sorry, I missed a minus here. So I can take the minus common actually, right? So dy by dx is equal to minus common. This turns into 3x plus 2y divided by 2x plus 3y. Let's match. 2x plus 3y, 3x plus 2y. Perfect. This is shown. Awesome. Let's move ahead to the next one. Hence, find the exact coordinates of the 2 points where the tangent is parallel to y plus 2x equals to 0. So parallel means having the same gradient. We have to convert it to the y is equal to mx plus c format. Y is equal to minus twice x. So the gradient is actually equal to minus 2. Now I can equate this one over here, the one that I have, with minus 2. Okay. Now I can get rid of the minus sign. 3x plus 2y is equal to 4x plus 6y. So ultimately I end up with minus 6 is equal to 4y. Now what's next? You have to use the main equation afterwards, or else it will never match. This is something that's unique to implicit differentiation. So we know that x is equal to minus 4y. Alright, so let's go. I can input this over here. 3 into minus 4y whole square. I think I missed a y over there, right? It didn't get copied. Plus 4 into minus 4y into y plus 3y square is equal to 5. So after we multiply this, what do we get? 4 square is 16, and the minus sign is gone. 16 into 3 is 48, right? So 48y square minus 16y square plus 3y square is equal to 5. 48 minus 16 plus 3, that is 35. 35y square is equal to 5, or y square is equal to 1 by 7 actually. That's a very weird answer, but it is correct apparently. So y is equal to plus minus root over 1 by 7. So we end up with y is equal to plus 1 by root 7, and y is equal to minus 1 by root 7. That is one of them. Now we know that x is minus 4y. So one of them is x is equal to minus 4 into plus 1 by root 7. So x is equal to minus 4 by root 7. And the other one is x is equal to minus 4 into minus 1 by root 7, which is x equals to plus 4 by root 7. Okay. Now, what are the pairs then? When x is negative, minus 4 by root 7, y is positive, plus 1 by root 7. And in the other one, When x is positive, plus 4 by root 7, y is negative at minus 1 by root 7. Okay, that is our final answer. See if this is fine, guys. Implicit differentiation, yeah? Okay, moving on to the last three, I'm guessing. Oh no, last four. 8, 9, 10, 11. P3 is rather difficult compared to P1. It's a longer paper, much harder. The variables x and y satisfy this differential equation. It is given that when y is equal to 0, then x is equal to 1. Solve the differential equation, obtaining an expression for y in terms of x. Okay, so we have to bring the y's on one side and the x on the other side, right? So we can write that dy by dx is equal to 4 plus 9y squared divided by e to the power twice x plus 1. So after cross multiplication, what do we get? 1 divided by 4 plus 9y squared into dy is equal to 1 divided by e to the power 2x plus 1. 1 divided by e to the power 2x plus 1 into dx. And I can put the integral sign on both sides actually. That's good. Now, how are we gonna deal with this? What is the rule? So as you can see, this one on the left hand side bears a resemblance with the tan inverse formula. I'm going to show you the booklet over here. Where is it? Here. The differentiation of tan inverse x is 1 divided by 1 plus x squared. And the integration of 1 divided by 1 plus x squared is equal to tan inverse x. Let me actually show you something, like how it's done. So the typical rule is, whenever you're integrating this, you need to ensure that the number with y square has been taken care of, because we know that d by dx of 1 divided by, what is it, 1 plus x square or x square plus 1, same thing. You can take a look at the booklet over here. 1 plus x square is equal to tan inverse of x, right? So we can do the same thing, but you need to ensure that you've taken the 9 common. So if I do this 1 by 9, what do I end up with here? 1 divided by 4 by 9 plus y square dy is equal to, and to integrate this one you just have to bring it above. This is e to the power minus 2x minus 1 dx. Now I'm just going to take one more step. 1 by 9, this can be written as 2 by 3 whole square plus y square dy is equal to this e to the power minus 2x minus 1 dx. Now it's fine. Now let's do the integration. What do I end up with? 1 by 9 into, basically it's going to turn into tan inverse. Always remember y, the one y or x divided by 2 by 3, and here 2 by 3 is going to go to the denominator. It is basically 1 divided by 2 by 3, which after reciprocal 1 divided by 2 by 3. Let me show you all the steps. And this turns into e to the power minus 2x minus 1 divided by minus 2 plus c. Okay, so after reciprocal this turns into 1 by 9 into 3 by 2 tan inverse 3y by 2 is equal to minus half e to the power minus 2x minus 1 plus c, or 1 by 6 tan inverse 3y by 2 is equal to minus half e to the power minus 2x minus 1 plus c. That is all. Now we need to find an expression for y in terms of x. We know that when y is equal to 0, x is equal to 1. Okay, y is equal to 0, x equals to 1. Tan inverse 0 equal to minus half e to the power minus 2 minus 1 plus c. So tan inverse 0 is actually 0 minus half e to the power minus 3 plus c. So we actually end up with c is equal to half e to the power minus 3, or essentially c is equal to 1 by 2 e cube. Now if I write down the equation again, it was 1 by 6 tan inverse 1 by 6 tan inverse 3y by 2 is equal to minus half e to the power minus 2x minus 1 plus c. So c is actually 1 by 2 e to the power minus 3, right? Now they've asked us to make y the subject. They want an expression for y in terms of x. Okay, that's doable. So we have to deal with this carefully, okay? Because if you mess up, um, it's gonna be wrong. So we're just gonna deal with it carefully. Like if we do this, we get 6 marks out of 7. Now we got 6 out of 7 marks. Out of the 7 marks, we got 6. But for the final step, there's 1 extra mark. Okay. So let's take a step-by-step approach. I'm gonna multiply the 6 on that side. Tan inverse 3y by 2 is equal to 6 into half is 3, right? Minus 3 e to the power minus 2x minus 1 plus 3 e to the power minus 3. Okay. What is the next step? Make y the subject. So tan is gonna go on that side. 3y by 2 is equal to tan 3 e to the power minus 3 minus 3 e to the power minus 2x minus 1. And finally, y is equal to 2 by 3 tan 3 to the power minus 3 minus 3 to the power minus 2x minus 1. Very good. That is our answer. Next part, state what happens to the value of y as x tends to infinity. Give your answer in an exact form. We know that y is equal to 2 by 3 tan 3 to the power minus 3 minus 3 to the power minus 2x minus 1. So as x tends to infinity, what is this equation actually? 2 by 3 tan 3 to the power minus 3 minus 3 divided by e to the power 2x plus 1. So think about it, as e to the power 2x plus 1, as x tends to infinity, this e to the power value will become really high. So 3 will be divided by infinity. Suppose 3 divided by, try doing this in your calculator, 3 divided by e to the power 1000, what value do you get? 3 divided by e to the power 1000, or 3 divided by e to the power 100. It's a very small value. Basically, as x tends to infinity, since the denominator is going to be so damn high, this whole value will turn to 0. So ultimately we're going to have y is equal to 2 by 3 tan 3 to the power minus 3, because that value is going to be 0, and that is our answer. We just had to realize that as x tends to infinity, 3 to the power e to the power 2x plus 1 actually turns to 0. Okay, that's what you needed to know. Awesome. And we're in question number 9 now. So this is partial fractions. You need to know the formula first. So we can write that fx is equal to, so we have a whole square here and 1 here, and this is in fact a proper fraction because it's x squared divided by x cubed at the bottom. Okay, so it's going to be a divided by 1 plus 2x. It's not being divided by 2x squared minus 3 or something, so no bx plus c on top. It's just a divided by 1 plus 2x plus b divided by 2 minus x once, and then c divided by 2 minus x whole square. If you ever see whole square, you need to consider it twice. So yeah, we can actually write 2x squared plus 17x minus 17 divided by 1 plus 2x 2 minus x whole square is equal to a times 2 minus x whole square plus b times 1 plus 2x and 2 minus x plus, I don't have enough space, plus c times 1 plus 2x, and the whole thing is divided by the LCM, 1 plus 2x 2 minus x whole square, which we can get rid of on both sides. So ultimately we end up with 2x squared plus 17x minus 17 is the same as a times 2 minus x whole square plus b times 1 plus 2x 2 minus x and c times 1 plus 2x. Okay, now to solve this simply you have to go for let x equals to 2. So what do you get? 8 plus 34 minus 17 is equal to, this is 0, this is also 0, 2 to the 4, 4 plus 1 5 plus 5c. So 8 plus 34 minus 17, 25 is equal to 5c, c is equal to 5, this one. And for the other one, what do we have to input? We need to ensure that this becomes 0. So I'm going to go for minus half, right? X equals to minus half. So what do you get? Minus 0.5 whole square into 2 is half. Minus 17 by 2 minus 17 is equal to a times 2 plus 0.5, which is 5 by 2 whole square, which is 25 by 4. And this is 0, this is also 0. Now 0.5 minus 17 by 2 minus 17, that is minus 25, is equal to 25a by 4. So a is equal to minus 4. Okay, fine. Now for c, you just need to put a random value like x equals to 0. So yeah, we have 0 plus 0 minus 17 is equal to 4a plus b into 1 into 2 plus c into 1. Okay, so we get minus 17 is equal to minus 16 plus 2b plus 5. So minus 17 plus 16 minus 5, that's minus 6. 2b is equal to minus 6, b is actually equal to minus 3. That is our answer. Okay, so a is minus 4, b is minus 3, and c is 5. That is all. Now we need to integrate this. At first we need to express it in terms of partial fractions. We have to show that it's 5 by 2 minus ln 72. Okay, so let's write the equation again. This one over here. Let's do this. So we know that if x is equal to, a was minus 4 divided by 1 plus 2x, b is minus 3 divided by 2 minus x, and plus 5 divided by 2 minus x whole square. Now let's integrate this. So to integrate this, what we have to do is, this is fine, minus 4 divided by 1 plus 2x. This is also fine, minus 3 divided by 2 minus x. And for this one, it's going to turn into 5 into 2 minus x to the power minus 2 dx. Let's do it. Okay, let's go. So yeah, this is going to turn into minus 4 ln 1 plus 2x divided by, the differentiation of 1 plus 2x is goes to the denominator. Then we get minus 3 ln 2 minus x, and the differentiation of 2 minus x is minus 1 in the denominator. And for this one, don't mess up, we don't use ln over here. It simply turns into, you learned this in add math O levels, plus 5 into 2 minus x to the power minus 1. The power increases by 1. The new power will go to the denominator, and the differentiation of 2 minus x, also minus 1, goes to the denominator. Okay, and what are the limits? I think the limits were 1 and 0. Okay, let's put this inside here. So after simplification, what do we get? Minus 2 ln 1 plus 2x plus 3 ln 2 minus x minus minus plus plus 5 by 2 minus x 1 0. Now input, what do we get? Minus 2 ln, what is it? 1 plus 2, that is ln 3, plus 3 ln 2 minus 1 is 1, plus 5 divided by 1, plus 2 ln 1 plus 0 is 1, minus 3 ln 2 minus 0 is 2, minus 5 divided by 2. So what do we get finally? Minus 2 ln 3, this is 0, this is 0, plus 0, plus 5, plus 0 again, all ln 1 is 0, minus 5 by 2. So what is 5 minus 5 by 2? It is actually 5 by 2. And for this one, minus 2 ln 3 and minus 3 ln 2, what can we write it as? This can be written as 3 square, which is ln 9 minus ln 9, and this can be written as minus ln 2 cube, which is 8. So that is that is 5 by 2 minus, if you take the minus common, it's ln 9 plus ln 8, which can be written as 5 by 2 minus ln 9 into 8, which is ln 72. That is shown. Okay, that's how we do it. Moving on to the last two sums for the paper. The diagram shows this curve y is equal to x plus 5 root over 3 minus 2x at its maximum points. Find the point M. Find the coordinates of the maximum point. Okay, let's do this. So we know that to do that, we have to go for dy by dx equals to 0. So let's differentiate this. 1 times root over 3 minus 2x plus x plus 5 into half, then 3 minus 2x to the power minus half, and we also get a minus 2 over here. We have to equate this with 0. So this can be written as 3 minus 2x to the power half. We can get rid of these 2's, minus sorry, wait, minus x plus 5 times 3 minus 2x to the power minus half is equal to 0. So I'm going to teach you a trick. Always remember this. Whenever you have a minus half and plus half, you can apply this technique. You can take the minus 1 common. So what do you get? 3 minus 2x to the power minus half. If you take that common, inside you will end up with 3 minus 2x to the power 1. This turns, the power turns into 1, and here it is x plus 5, and since you've taken this out, you only have 1 over there. How is this possible? You guys know that you can take minus half from this since it's the same thing, but how did I take it from plus half? Check this out. The plus half one can be written like this: half into 3 minus 2x to the power minus half divided by 3 minus 2x to the power minus half. Rationalization. So I just took this out. Now if you make it go to the top, what would you get? 3 minus 2x to the power plus half. So half plus half turns into 1 when you take this one out from the equation. Okay, so that is the logic behind this. You will see me do this quite often. Okay, so now this one over here can't be solved, so that's out. So we finally end up with, so this 3 minus 2x to the power minus half cannot be equal to 0. On the other hand, 3 minus 2x minus x plus 5, sorry, minus x minus 5 is equal to 0, or minus 3x minus 2 equals to 0, 3x equals to minus 2, x equals to minus 2 by 3. Yeah, it is a negative value, minus 2 by 3. Now coordinates, we need to find out the y coordinate. Y is equal to x plus 5 into root over 3 minus 2x. So y is equal to minus 2 by 3 plus 5 root over 3 plus 4 by 3. Minus 2 by 3 plus 5, which is 13 by 3, and root over 3 plus 4 by 3, that is 13 by 3. Whoa, that's weird. Root over 13 by 3. Okay, so let's try multiplying that. 3 plus 4 by 3. Root over answer into 13 by 3. We actually end up with y is equal to 13 root 39 by 9. That is the simplified form. Okay, so what are my coordinates? They are actually 2 minus 2 by 3, 13 root 39 by 9. Okay. That's great. Using the substitution, u is equal to minus, so u is equal to 3 minus 2x. Find by integration the area of the shaded region bound by the curve and the x-axis. Okay, so we need the limits first. Yeah, so let's try to do that. We know that y is equal to x plus 5 and 3 minus 2x. So when y is equal to 0, one of them is x equals to minus 5, the other one is root over 3 minus 2x equals to 0, or 3 minus 2x equals to 0, or x is equal to 3 by 2. I have my limits, minus 5 and 3 by 2. Awesome. Now, how do we do this? We need to find by integration, right? Let's do it. So I'm going to integrate x plus 5 and root over 3 minus 2x dx. Okay. So this is integration by substitution. Okay. So let's take a step-by-step approach. So we know that u is equal to 3 minus 2x. So du by dx is going to be minus 2. So now I need to substitute that. Dx is equal to minus du by 2, right? Dx is equal to minus du by 2. I just did the math. Now, if we input it over here, 3 by 2 and minus 5, we can write x plus 5 over here. What can we write in the place of root over 3 minus 2x? We can just write root over u here. And in the place of dx, I can write minus du by 2. Now the issue arises that we cannot have any x's left in this equation. Okay, now what? So, you gotta do something else when you put the u in. You gotta change the limits now, okay? And we also need to substitute this x over here. So we know that, I'm going to use another pen color. We know that u is equal to 3 minus 2x. So 2x equals to 3 minus u, or x equals to 3 minus u by 2. Also, we can find out the limits, new limits. How? I want to find out u, right? So once I'm going to put in 3 by 2, u is equal to 3 minus 2 into 3 by 2, which is 3 minus 3, or u is equal to 0. This is the upper limit, while the lower one is u is equal to 3 minus 2 into minus 5, which is 3 plus 10, which is 13. So my new limits are 0 and 13. I know that it might seem odd, how is the lower one higher, but trust me, just don't change their places, okay? And now I'm going to substitute in the place of x this part 3 minus u by 2. So 3 minus u by 2 plus 5 times root u into minus du by 2. I'm going to take one more step for LCM. So 3 minus u plus 10 by 2 root, so I wrote root 3 over here, it will be root u minus du by 2. Now what I can do is I can take the 2 out. I can write this as 1 by 4, 0, 13. What do I get? 13 minus u times root u into minus du. Okay, now we got to deal with the minus sign, so it turns into 1 by 4. So 13 into root u, that's 13 root u, and the sign changes to minus 13 root u, or u to the power half, and here it turns into root u into u, that is u to the power 3 by 2, plus u to the power 3 by 2, right? Plus u to the power 3 by 2 du. That is all. Now we can go for our final step, which is the integration. So yeah, 1 by 4, after you integrate, it turns into u to the power 5 by 2, and this is 2 by 5 after reciprocal, and this turns into minus u to the power 3 by 2. So 13 divided by 3 by 2 is in fact 26 by 3. I just used the calculator. I'm gonna use the limits 0 and 13. So 1 by 4, 0 minus 0 minus 2 by 5, 13 to the power 5 by 2, plus 26 by 3, 13 to the power 3 by 2. Okay, so minus 2 by 5 into 13 to the power 3 by 2. Do they want an exact answer? Giving you answer in the form a root 13. Interesting. Okay, 13 to the power 5. 13 to the power 5 by 2. What does that mean? It's 13 to the power 5, or it's basically 13 to the power 2.5. So that basically means 13 square in 13 to the power half. So we can write it like that, okay? Because they wanted in this form, in the root 13 form. So that's the tricky part actually. So alright, let's do it. I'm going to take another step. Minus 2 by 5 into 13 square into 13 to the power half actually means root 13 plus 26 by 3 into, what does 13 to the power 1.5 mean? It is 13 to the power 1 into 13 to the power 0.5, which is basically 13 times root 13, like that. Okay, so one more time. Okay, so let's do this. 13 square into 2 by 5, which is minus 338 by 5 root 13, plus 26 into 13 by 3, 338, which is 338 by 3 root 13. Okay, now let's just break down the brackets. So minus 338 by 5 into 1 by 4. Oh, we can actually simplify this, can't we? Because both of them have root 13. Minus 338 by 5 plus 338 by 3. So that is 1 by 4 times 676 by 15 root 13 into 0.25, which is giving me an answer of 169 by 15 root 13. So yeah, my students were complaining about this sum. They said that it was quite difficult when they did the exam. So yeah, it is 169 by 15 root 13, where a is 169 by 15. You can mention that. Okay, so yeah, quite a complicated sum. It took a lot of steps to do. So yeah, pretty complicated. One of the hardest sums of integration by substitution, honestly. Last question then, let's wrap things up. So the points A and B have position vectors these two, and the line L has equation R is equal to this. Show that L does not intersect the line passing through A and B. So let's find out the equation of the line. So OA is equal to 1, 2, minus 2, and OB is equal to 2, minus 1, 1. So AB is equal to OB minus OA, which is 2 minus 1 1 minus 1 2 minus 2. Okay, so what do we get? 2 minus 1 is 1, minus 1 minus 2 is minus 3, 1 plus 2 is 3. All right, now we have to find the equation of the line passing through AB. How? So it is, what letter have they used? Mu. So I'm going to use lambda. So the equation of the line is going to be a position vector. Basically it's like this, AB. So we have to use a position vector OA followed by the lambda times the direction vector. Okay, so the equation of the line is respectively, I'm going to use OA 1 2 minus 2, or it's OA plus lambda times AB. 1 2 minus 2, 1 2 minus 2 plus lambda times 1 minus 3 3. This is the equation of the line passing through AB. Okay, now we need to show that they don't intersect. So let's do that step by step. So here you go. I can also write this as 1 plus lambda, 2 minus 3 lambda, minus 2 plus 3 lambda. That's one. And the other one is the one that's given, R. It is 1 minus 1 3, 1 minus 1 3 plus mu into 2 minus 3 4, mu into 2 minus 3 4. Okay, so R is equal to 1 minus 1 3, sorry, plus 2 mu minus 3 mu plus 4 mu. So we need to equate the two of these to see if they match. Let's try. So the first one being 1 plus lambda equals to 1 plus 2 mu. So we get this relation, mu or lambda is equal to 2 mu. That's one. Now for the other one, 2 minus 3 lambda equals to minus 1 minus 3 mu. So 3 is equal to 3 lambda minus 3 mu. Now we can introduce this over here. So let's try doing that. 3 is equal to 6 mu minus 3 mu. So 3 is equal to 3 mu, or mu is equal to 1. Okay, for example, I got that mu is equal to 1. Um, there are other variations, like in the mark scheme, some of them are given. So what will the value of lambda be? Lambda is equal to 2 times 1, which is 2. So yeah, this is one variation where I get mu 1 and lambda is equal to 2. You could get other variations though. Like you guys could get, all of them are mentioned in the mark scheme. I'm gonna explain. Um, Others are mu is minus 2 and lambda is minus 1. Mu is 5 by 2 and lambda is 5. If you use the other combinations, and if you used OB as the position vector rather than OA, there are three variations. You can 1 1 4 5 by 2 and minus 2 minus 2. Okay, I got these because I used these two. You could also solve them using this one and this one, 1 3. Then you could also go for 2 3. That is why we get three sets of results. Okay, now if you try to input them here, if you input lambda is equal to 2, you are going to get 1 plus 2, which is 3, 2 minus 6, which is minus 4, and minus 2 plus 6, which is plus 4. I tried to input this, and here if we input this, what do we get? 1 plus 2, which is 3, minus 1 minus 3, which is minus 4, 3 plus 4, which is 7. The two you've used to solve the equation will always match. Okay, so the important part is that you show that the last one, okay, clearly the last one does not match. So we can say that, you know, they are not satisfied. You need to verify, and then you need to say that therefore you know that 3 minus 4 4 is not equal to 3 minus 4 7. You need to mention that, okay, clearly. Now find the position vector of the foot of the perpendicular from A to L. Okay, so let's try to draw a diagram, then things will be clear. So basically, what is L? L is probably something like this. Maybe this is the line L. Now look at A. Maybe A is somewhere over here. A is somewhere over here. Now what do they want us to find? They want us to find the foot of the perpendicular from A to L. Position vector of this point over here, x, we can call it x. So we essentially need to find OX, this point over here. So yeah, what we can just use the dot product of AX and the direction vector of the line, right? And then we can just use that dot product and equate it with 0. So let's try doing that. How to do it? Come on. So at first we need to find a general point on line L. So what was the equation for line L? It was like this. This is the equation for line L. So x is over there maybe. So what do we need to find? We need to find the direction vector of AX. So AX is OX minus OA. So this equation on the left, you see this one? This one over here is OX. This is a general equation for any point on line L. Now what is the value of OA? OA is 1, 2 minus 2. So what do we get? 1, 1, 2 minus 2. Minus 1 minus 3 mu and 3 plus 4 mu. Okay, let's do this. So AX is actually equal to 2 mu, then minus 1 minus 2, minus 3 mu, and 3 plus 2, which is 5 plus 4 mu. This is the equation for AX. Now we are going to apply the dot product of whom? AX and the direction vector of line L. What is the direction vector of line L? 2 minus 3 4. 2 minus 3 4. This one. 2 minus 3 4. Okay. So we know that the dot product 2 minus 3 4, the dot product with the vector AX which is 2 mu, and minus 3 mu, and 5 plus 4 mu. So this dot product will be equal to 0 since they are perpendicular to each other. So we end up with 4 mu plus 9 mu plus 20 plus 16 mu is equal to 0. 29 mu and 9 plus 29, sorry, 9 plus 20 on the other hand, is equal to minus 29. So mu is equal to minus 1. This is the value which I'm getting. Now finally, what are we asked to find? The position vector of OX. Okay, so we know that OX is equal to 1 plus 2 mu, then minus 1 minus 3 mu, and 3 plus 4 mu. Now I just need to input minus 1 over here. So OX is equal to 1 minus 2, which is minus 1. Minus 1 plus 3, which is plus 2. And 3 minus 4, which is minus 1. This is my final answer. So we can write that OX is equal to minus I plus 2j minus k. Although this one was fine as well. Okay. So yeah, guys, that was the paper. It was a relatively hard paper. As I've heard, it wasn't that easy. There were a few hard sums, especially question number 10. I think 10 part B was extremely difficult. But overall, yeah, it was alright. So yeah, please do comment below if you have any problems or if I've made any mistakes. I plan to do the other P3 papers as well. So if you like the content, please remember to subscribe to the channel and consider supporting me on Patreon, where you get access to all the solved papers and video calls with me, etc., as well as my notes for physics, chemistry, and other topics. So quick shout out to my $15 patrons for the month. We have Dewa, Luna, and Sean. Anyway, I'm gonna link the paper for 9709, paper 3-1, May June 2023 over here, and May June 2023 paper 3-3 when I solve those, and I'll link the playlist for P3 over here. And remember to subscribe to the channel. See you guys.